Hi, have you heard of a force field in science fiction movies? Where such field apply forces at a particular position in space to keep a villain trapped or to protect a spaceship from enemy fire? The concept of a field is very useful in physics, although it differs somewhat from what you see in movies. A field is a way of conceptualizing and mapping the force that surrounds any object and acts on another object at a distance without apparently physical connection. For example, the gravitational field surrounding Earth and all other masses represents the gravitational force that would be experienced if another mass were placed at a given point within the field.
Our main topic for today's video is all about electric field, which is presented by Group 5 of Grade 12 Spirulina. There are two objectives. First, describe an electric field as a region in which an electric charge experiences a force. Second, calculate the electric field of a point charge.
Michael Faraday, an English physicist in the 19th century, proposed the concept of the electric field. He defined that an electric field is an imaginary line or curve that drawn through a region of space so that its tangent at any point in the direction of the electric field vector at that point. So an electric field is a region of space in which an electric charge experiences a force and electric field are caused by an electrical charge. Where there is an interaction with one charge to another is because of the field or imaginary line of an electric field. For example, in electron and proton, they have imaginary field that is what we call electric field and represented by electric field lines.
Electric field by a charged object. So electric field can be mathematically defined as E is equals to F over Q, where E is the electric field, F is the force, and Q is the magnitude of test charge. So based from this equation, we can conclude that electric field is equal, or electric field is the force per unit charge. It is measured in terms of Newton per coulomb. So the unit of electric field is Newton per coulomb. We should always remember that. Another equation of electric field is based from the Coulomb's law. If we substitute the value of Coulomb's law to the F, it is K multiplied by the test charge and point charge over the distance squared. So we can cancel one charge. We cancel these two test charge, and all that will be left is E is equals to K, or the Coulomb's constant, which is equivalent to 9 times 10 raised to 9 Newton meter squared per coulomb squared, multiplied by Q, which is the point charge, over R squared, the distance.
So, electric field can be illustrated through electric field lines, and every charged particle has some sort of presence of distinct field lines, specifically the protons and electrons. So, what does electric field lines of protons and electrons look like? Well, consider two charge of proton, which is positively charged, and electron, which is negatively charged. If we bring some sort of test near a positive charge, there will be like a repulsion between them, and the test charge will like move away in outward direction. So we can say that electric field lines originate as positive charges. Secondly, if I bring a test charge near a negative one, there will be like a attraction between them. So we say that electric lines terminate on negative charges. And also the imaginary lines that indicate directions of electric field is called electric field lines. Secondly, we can also define electric field lines as a path along which positive charge would move if allowed free.
column exert of a force 2.4 times 10 raised negative 4 Newton, and the right side of the positive test charge. What is the magnitude and direction of the electric field at the location of the test charge? So first, mag-himo tag diagram which is plus and circle whatsoever para mas masabtan nato ang problem. So kanina microcoulomb, kaning 6 microcoulomb is in the right side of a positive. So muhatag og N for Newton, meaning it is a force. So F equals 2.4 times 10 raised negative 4N. Then ihatag og charge which is 6 microcoulomb, which is Q equals 6 microcoulomb. Micro stands for times 10 raised negative 6C. Dapat inyong mga charge, mga na-coulomb, and dapat naka-measure sila tanan. So kung given ang force, you use the formula E equals F over Q. F stands for force and Q stands for charge. So F equals 2.4 times 10 raised negative 4 Newton, and Q4 equals 6 times 10 raised negative 6C. So atong gamiton nga formula ha is E equals F over Q. When you use scientific notation, putting ang parentheses like this, and E equals F over Q. So nga na, 2 times 2.4 times 10, negative 4 raised negative 4 Newton over 6 times 10 raised negative 6 and C. For example is open parenthesis 2.4 times 10 raised negative 4 Newton close parenthesis over 6 times 10 raised negative 6 C and close parenthesis. So that's the final answer. 40 unit is Newton per coulomb, so the answer is 40 Newton per coulomb. Positive test charge mahimong left side kay repulsive.
So question number 2. What is the magnitude and the direction of electric field 0.10 meters on the left hand of a negative 4.2 microcoulomb charge? So, example diri. We have two charges, which is the right side positive and the left side negative. So, sa atong problem, nakabutang diri na the left hand of a negative 4.2 microcoulomb charge. Itong nabutang diri, the negative, the left side man. And the direction of electric field is 0.10 meters. So, itong nabutang diri, 0.10 meters. So, ang formula na itong gamiton is E equals to KQ over R squared. So, A equals to K, which is the equivalent of 9 times 10 raised to 9 Newton meter squared per coulomb squared, times the equals of Q, which is negative 4.2 times 10 raised to the negative 6 coulomb, and divided by R2, which is 0.10 meters squared. So, now, we're gonna multiply the K and Q given. We're gonna cancel the column and the column squared and multiply these two. So, this is the answer we got by multiplying those two. And we multiply by itself the R squared with R squared, which is 0.10 meters squared. So now, we're gonna cancel the meter squared and the meter squared here so that we can divide it. Negative 37.8 times 10 raised to 3 Newton per coulomb divided by 0.01. So the answer is negative 3,780,000 Newton per coulomb.
Number 3. Two charges, negative 2 times 10 raised to negative 7 coulomb and 3.4 times 10 raised to negative 7 coulomb are 4 meters apart. What is the magnitude and direction of electric field at a point midway between the two charges?
Since kay 4 meter apart man, magbutang kay 4 meter apart rin. Then, what is the magnitude and direction of electric field at a point midway between the two charges? Midway means ang test charge is na sa tunga, so maghimo ta og bag-o nga diagram. Mao ni ang test charge, then mao ni ang duha ka given. Mao ni ang negative 2 times 10 raised to negative 7 column and positive 3.4 times 10 raised to negative column. Mao ni ang test charge. Since kay natunga naman sila, ato pong i-divide ang 4 into 2. Mao nang mahimong 2 meter. So, ang kabuuan nila is 4. So, kay tulo naman sila, tulo na ka-charges, 3 charges naman, ang atong himuon, ang atong gamiton nga formula is, E equals to K times Q divided by R squared. Then, ang una natong isolve is kaning negative. So, E equals to K ng equivalent is 9 times 10 raised to 9 Newton meter squared per column squared times 2. Negative 2 times 10 raised to negative 7 column divided by ang ilang distance, 2 meter squared, kani. So, ang answer is negative 49.4 Newton meter per column. Then, mao ni. So, ang next na itong akwaon is kanina pong positive charges. Maura gihapon ang process. Then, ang 2. Cancel out. Mo na ni ang answer. So, since ang ilang direction is pa left man, ang kanisiya mahimo na ning negative. Mo nang ato sa sidyang i-plus, then i-change ni to negative. I-plus na to ang E1 plus E2. Ang ilang direction is to left. Mo nang kay negative naman ni daan, dili na usbon. Then ang kanimo ni mausob into negative. Answer is 1.213.39 Newton per column. So, mauna ni ang ilang midway.
Properties of electric field lines. Number 1. Electric field lines are imaginary. Number 2. They never intersect each other. Number 3. If electric field is stronger, field lines are closer. Number 4. Electric field is perpendicular to the surface of the charge. Number 5. The number of field lines is directly proportional to the magnitude of a charge. Last, 6. If the charge is single, then they start or end at infinity.
Alright, that's it. I hope you learn and enjoy our video. Thank you so much for listening.